All right, let me introduce you to some basic terminologies that you'll be needing in physics. For example, physical changes, chemical changes, scalar quantity, vector quantity, base quantity, derived quantity, all of this. We'll understand the concept of each of them and we'll be recognizing them from some examples. So to begin with, physical change is a change that does not alter the chemical composition of a substance. Let's say melting of ice. When ice melts, you get water. It's just changing its physical form, solid into liquid. Water is not changing into something else. It's just water from solid form into liquid form. So it's a physical change. Similarly, boiling water, breaking glass, these are physical changes. On the other hand, chemical change is a change that makes new substances with different chemical properties in it. Okay, let's say rusting of iron, burning of paper, cooking food. These are irreversible, you can say. So these are chemical changes. Okay, the chemical composition of the substance changes. That kind of change are called chemical change. Okay, now scalar quantities have only value. Let's say a car has a speed of 60 kilometers per hour. You're not saying in which direction this car is moving. You're just saying that the speed is 60 kilometers per hour. You're only talking about the value here, no direction. So that kind of quantities are basically scalar quantities. They have value, in other words, magnitude, but there is no direction in them. Okay. Similarly, when you talk about mass, let's say it's 5 kilogram of mass. This object has mass of 5 kilograms. You're not saying in which direction it has 5 kilograms. It's only value. So let me walk you through some examples so that you get familiarized with the scalar quantities. Okay, so distance is a scalar quantity. Speed, time, mass, temperature, energy, work, power, density, pressure, volume, area. These are all scalar quantities. Okay, so in the exam they might ask you to write the definition of scalar quantity and some examples. You can define that scalar quantities have only magnitude or value and they don't have any direction, and you can list some examples from here. Okay. On the other hand, vector quantities have value and direction. Let's say again this car has 60 kilometers per hour speed, but you're saying that this is moving towards east. Okay, you're giving it a direction. If something has value and direction, that kind of quantity is basically a vector quantity. Okay, so again, let me walk you through some examples. Displacement is just distance in a particular direction. Okay, velocity is speed in a particular direction. Acceleration, of course, if you're accelerating a car, it has a direction that it is moving. Deceleration is just the opposite. Okay, opposite of acceleration. Force, weight. You know that weight is downward pulled towards the center of the earth, so it has a direction downward. Momentum as well. These are vector quantities. Again, learn the definition and examples. Okay. Now, base quantities. As the name suggests, base quantity is a fundamental quantity. Okay, they are independent. They don't depend on any other quantity. So mass is base quantity. Length of any form is base quantity. Let's say length, in other words, we can say breadth or height or width. It can be in any form, but this is a base quantity. Time is a base quantity. Temperature is also a base quantity. Okay, so base quantities are fundamental quantities that are independent. Okay. On the other hand, derived quantities are dependent. They depend on the base quantities or other derived quantities. Okay, so quantities that are derived from base quantities are basically derived. Okay, examples can be area. Let's say if you talk about area of a rectangle, area of a rectangle is length multiplied by breadth. So you're multiplying two base quantities to get this derived quantity. Similarly, volume of a rectangle can be L into B into H. So you're deriving it from these quantities. Speed is distance over time. So distance and time are base quantities. You're deriving speed from it. Okay, velocity is just speed with direction. Acceleration is gain in speed, change in speed over change in time. Okay, force, we get it from mass times acceleration. Okay, pressure, energy, work, heat, power, momentum, these are all derived quantities. So to recapitulate, physical changes do not alter substances composition, chemical changes do. Okay, scalar quantities have only value. On the other hand, vector quantities have value and direction. Base quantities are fundamental quantities that are independent, and derived ones come from base quantities. That's all. Thank you.